You can put the heading kinetic theory of gas. Short form में I call it KTG. Now, point is, first of all, try to understand what are the points in this, what are the postulates in this, what are the assumptions in this. First of all, it is only applicable for ideal gas. Only applicable for ideal gas. It is not applicable for real gases. In this, we assume intermolecular forces will be negligible. In this, we can assume volume of particles can be negligible. When the particles are moving randomly in a container, they can collide with each other and also with the wall of containers, so that its total energy will be remaining constant. So during collisions, there should not be loss of energy. So if you start writing, following are all are simple points. Only 3 points are important. I'm telling you. One is intermolecular force, that is negligible. One is a volume of particles as compared to the volume of container will be negligible. And third is kinetic energy. Average kinetic energy is directly proportional to the temperature in Kelvin. These 3 points you must keep in mind. And remaining points, if you missed also, it will not affect much during problem solving. You can start writing with me also. So first point is very simple. All particles are of same size, shape. These are rigid. If it is rigid, you cannot deform the shape. The volume occupied by particles of gas is negligible. I discussed already when I compared the properties of solid, liquid and gas. The particles ki volume will be negligible as compared to volume of container. See, it is random as well as straight line. It means sometimes it is moving in this path, and sometimes after striking the wall, it can move in a different angle. The path is not fixed, but it will be always straight line whenever it is moving.
So direction fixed नहीं है ना?
Direction is not fixed. Perfectly elastic means what? There should not be any loss of energy. In elastic collision, loss of energy is completely taking place. Partially होगा तो थोड़ा absorb होगा, थोड़ा मिल जाएगा. This is a new thing. If one particle is colliding with the wall of container, again it will rebound back from the wall. Again it is colliding. The average distance between the two collisions is known as mean free path. I will tell you that formula also. Mean free path. It is denoted as lambda.
सर यार नोट शेयर कर दोगे ना?
हाँ हैंड कर देंगे. You write ना बेटा. Why
सर
do you?
मेरे को एक्चुअली कल वैक्सीन लगी है, इससे बहुत दर्द हो रहा है. कोशिश कर रहा हूँ सर, बट वो
हाँ, that is a different case. Whatever I will teach, what I will share it. Na? But in future, you just if I tell you to write in the class, you write in the class so that your time will be saved. Sometimes I will be not having time. So I will tell you, I will discuss the theory, and I will tell you to finish at home. Now just follow the class, the lesson properly. That is enough, I guess. And topics are not difficult. Very simple topic. तो कहता है जब कोलाइड करता है तो कोलाइड करेगा, it will be in contact with the wall of container. The time of contact that is negligible as compared to the time taken between two successive collisions. It will collide one time, again it will rebound back, and again it will collide with the same position or other position. We take always average because it is always in random motion. So the time of contact with the wall or with the other particle will be what? Negligible. Particle means gas molecules or gas atoms. If it is inert gas, I will tell you when we'll take the particle as atoms or inert gas. Inert gas does not have any molecule, so the particle will be atom. Other gases will be having what? Molecules. So you people have started already getting vaccinated. I think in this month you will finish. I think ना सबका खत्म हो जाएगा ना?
Yes, sir.
बढ़िया.
Yes.
Okay. In general, we refer this collision as molecular collisions because maximum gas particles are molecule. In general, it is referred as molecular collisions. The interparticle force of attraction among gas particles attraction जरूरत नहीं है. You can make it attractive as well as repulsive. There's no molecular interaction basically. There's no intermolecular interactions. सिर्फ collision होगा, but there's no force of attraction or repulsion. Newton's law of motion. The point I will tell you to just keep in mind. First is this volume wala point, and the second is this in-term particle force. And the last one, if you want to make it 10 points, you can add here. Although kinetic energy and speed of individual particles changes on interparticle collision, due to energy transfer but the average kinetic energy and average speed of particle remains constant. That is average kinetic energy of gas molecules, gas particles कह लीजिए, is directly proportional to absolute temperature of gas. Absolute temperature means, I told you 2-3 times in the class.
minus 273 K.
No, that is absolute zero. That is 0 Kelvin. Absolute temperature means the temperature in Kelvin only, nothing else. Absolute temperature means temperature in Kelvin. Average kinetic energy is proportional to T. Distribution of velocities does not change with time if temperature is kept constant. It means if in a container there are 10 particles, assume that there are 10 particles, and out of 10 particles, मान लीजिए we have 10 particles. Two particles are having v1 velocity, 3 particles are having v3 velocity, and 5 particles are having v4 velocity, v2 and v3 कर लेते हैं. v2 and v3 velocity. What will happen? The collision will take place. The collision will take place, but the number of particles having v1 velocity will not change. Particle can exchange the position. This particle will come here, this particle will come here. But the number of particles having velocity v1 will not change. That is known as distribution. The distribution of velocities does not change with temperature, with time, if temperature is what? Kept constant. If there are 5 particles at temperature T having v3 velocity, it will always remain with 5 particles. This particle can come here, this particle can come here due to collisions, but the number will not change. That is known as distribution. On this, I will give you one question. Let's try to solve it. Calculate the temperature at which the velocity, that is average velocity and energy, velocity of a gas molecule is doubled the velocity at 27 degrees Celsius. So you have to find the temperature at which the velocity of a gas molecule is double the velocity at 27 degrees Celsius. Try to find it. You have to apply this concept. So how many points we have to keep in mind for solving? The volume of particles wala, the interparticle force will be 0, and the 10th point. Are you done with the writing?
So 10th.
Yes, sir.
No, sir. लिख रहे.
Just finish it. And finish it and write the problem and try to solve it. Therefore, half mv square is proportional to what also t. So can we say that if mass is constant, v square is proportional to t? So v1 upon v2 upon v2 square upon v1 square is equal to t2 upon t1. Just like we did in different laws. The velocity at double the velocity at 27 degrees Celsius. So T1 is 300 Kelvin. T2 is unknown. If I take V1 is V, so V2 is 2V. So 2V square upon V square equal to T2 upon 300. So T2 will be 1200. Done, everyone?
So v square proportional to 2t आना चाहिए ना?
What?
So half mv square is proportional to t के 2.
half m square proportional to t, half and m is constant now. Half m is constant. Here also you will become 2t2 and 2t1. Now the
Sir,
2
क्योंकि k is equal to half m है इसलिए वो constant है.
half m is constant. The constant term can be removed now, it is proportional. So that's why we can remove the constant term. So mv square is proportional to t. ऐसा लिखते हैं. Constant term can be removed. So mv square proportional to t. And then v square proportional to t, because m is what? Constant. M is nothing but mass of
particle.
particle. स्पीड और वेलोसिटी हम सेम डिस्कस करेंगे, सेम यूज करेंगे. स्पीड लिखिए या वेलोसिटी लिखिए. Since gas particles are in random motion, we all know they are in random motion. Their speed change continuously from very low. Again, I will repeat, distribution of velocities will be constant if temperature is kept constant. It means the number of particles associated with a particular velocity will be remaining constant. The particle can change its position, but number of the particles associating with a particular velocity will be always constant. Now just try to focus on sentences. If I keep a constant temperature, the particles are in random motion, their velocities are continuously changing, so it is impossible to identify the velocity of a single particle at a particular time. What is always changing, but the number of particles associated with a particular velocity will be always remaining constant. Now you can see the example we have taken here. What is the fraction of total number of particles we have taken? What? How many particles you have taken in total?
10.
10 particles.
What is the fraction of particles having velocity v1?
Sir, 2 by 10.
2 by 10. Very
1
good.
by 5.
1 by 5.
Thick. Good. 3 by 10.
5 by 10.
And next is 5 by 10. So this fraction will be always fixed for v1, or number will be fixed with v1. Same thing goes here also. Since gas particles are in random motion, their speed continuously changing from low to very high values, so it is not possible to identify the velocity of single gas molecule at a particular time. Even though वेलोसिटी का स्पीड सेम ही रखिए, स्पीड ऑफ सिंगल gas particle changes continuously a fraction of total number of particles. Particle means molecules. In books, you will find always molecules, because except inert gases, all the particles are molecules only. If you change the temperature, then the velocity can change. Even though speed of single particle changes continuously, a fraction of total number of particles possess a definite speed at a particular temperature. These speeds or velocity are known as statistical speeds or velocities. There are three such speeds used in KTG. Simple KTG. There are three such speeds used in KTG. First is very simple subtopic we are discussing basically here, which are as follows. First one is average speed. It is the most simple. What is average? Addition of all the things divided by number. It is average of speeds of all particles. Symbol you can write U average. Symbol you can use U average or C average. Number of particles and speed of, if I say n1 particles having v1 speed, u1 कर लेते हैं, u1 speed, n2 particles having u2 speed, n3 particles having u3 speeds, like this. So what will be u average? N1 into u1 plus
N2 into U2 plus N3 into U3.
Upon total number of particles.
Still,
Where n is total number of gas particles. But actual formula, which is derived from an equation, call it Maxwell-Boltzmann equation, because it is given by Maxwell and Boltzmann only. The formula is what? After every simplification, 8 RT upon IM. It can be also written as 8P upon pi D. So this is a formula you have to keep in mind. It will be directly asked in the problem. Where, what is T? Temperature. M, molar mass of gas. Pi is a constant, 8 constant, R is a constant. P, pressure of gas. And D is density of gas. And you know that PV equal to nRT can be also written as PM equal to dRT. From this, RT upon M can be written as P upon D. So that is replaced by RT upon M is replaced by P upon D. Understood, Nitin?
yes, sir.
Formula you have to learn 8 RT upon pi. Did you write? Did you complete the writing also?
Yes, sir.
No, sir. Last का part बाकी.
Complete कीजिए. Sir, most probable speed or velocity UMP. हाँ. It is the speed possessed by higher fraction of molecules. Your particles. So can you tell me, the example taken, which velocity is most probable velocity? It is what V3, because V3 is having a 5/10 fraction of molecules. 5 molecules are having what? V3 velocity. Total particles is what? Total
10 particles.
particles. V3 is having maximum velocity. V3 is having not maximum velocity. V3 is having what? V3 possessed by what? Maximum number of particles. So 5 particles are having V3. So that will be most probable velocity. Average will be what? in this average will be what? 2 into V1 plus 3 into V2 plus 5 into V3 upon 10. Very simple. But the actual formula UMP is 2RT upon M or 2P upon D. 2P upon D. Next is root mean square speed or velocity, that is URMS. It is the square root of, the name will tell you the definition in reverse order. It is the square root of mean average. Mean means average or kuch nahi. Mean means what? Average of squares of speeds. So first you have to square the velocities, your speeds, then you have to take the average, then again you have to take a root. Square and root means what? Again you will get the velocity unit. If you square the velocity, the unit becomes meter square per second square. But if you take again the root, you will get the again unit of velocity or speed. First of all, I will write the formula of URMS. Then we'll move to that actual expression using the definition. URMS. RMS just try to keep as a suffix. Is written as 3RT upon M or 3P upon D. URMS can be written as, in a simple form, 1.58 to 10 power 4 root under T upon M centimeter per second. It means this is what? CGS unit. Therefore, M should be also in what? CGS. You have to maintain the unit basically. What is the value of R? In SI unit, 8.314 joule per mole.
Mole
per
raised to minus 1, Kelvin raised to minus 1.
the unit of energy in CGS unit. What is the unit of energy in CGS unit? Anyone?
Arg.
Erg. And 1 joule is what? 10 power 7 erg. Okay. Now, we try to write that generalized expression. Assume mass of one gas particle is M. N1 की velocity V1, N2 particle velocity is what? V को U ही रखने दीजिए. U1, U2, N3 is U3 like this. What is the square of U1? U1 square, U2 square, U3 square like this. ठीक है? N is total number of particles. है ना? Any doubt here?
No, sir.
सही है? What is the kinetic energy of one particle? Half mu1 square, half mu.
MU2 square.
बिल्कुल सिंपल तरीके से. This This is what? Number of particles. This is speed. This is square of speed. This is kinetic energy of one particle. Kinetic energy of one particle. If I ask you what is the average kinetic energy of one particle? Yeah, what is the average kinetic energy? Definitely it is of one particle. बोलिए, what happened? N1 particles की kinetic energy what? This
half mu1
half mu2 square ऐसे जाएगा upon
n1 plus n2 so
ठीक है. Any doubt?
no sir.
अच्छा, एक और we'll write it. URMS. What do you have to write? URMS is what? Read the sentence. It is the square root of mean of squares of speed. So what is the average of squares of speed? What is the average of squares of speed? बोलिए. Average of squares of speed क्या होगा? बोलिए. N1 into
n1 into u1 square plus n2 into u2 square plus so on upon n1 plus n2 and so on.
and root of this is what? URMS. Root of this is what?
URMS.
URMS. It is written. It is the square root of mean or average of squares of speeds. If I take m is common and half is common, if I take it out, half into m, in bracket it will become what?
n1 into u1 square.
It means this. Are you getting it? Hello?
Yes.
Now it can be turned out to be what? This is square of URMS. बोलिए. URMS
Yes, sir.
Yes sir.
करेंगे तो वही मिल जाएगा. So average kinetic energy of one particle is nothing but half m into URMS.
URMS square.
ठीक है. तो average m into URMS square. Please write properly. सब कुछ लिख लिया नितिन? Everything you have written?
So number of particles.
सर बीच दिखाओ ना
हाँ बेटा.
वेल
यहाँ से ओके. मैं पॉज कर देता हूँ रिकॉर्ड. आप लिखिए, कंप्लीट करिए आराम से. Here the velocity v is nothing but RMS speed, है ना? Because kinetic energy is written in terms of what? URMS. Hello? Are they clear, beta?
Yes sir.
Whatever velocity we are talking about there, that is root mean square velocity. And the most used velocity is what? Root mean square velocity. Comparison of velocities or speeds. You again write the velocity speeds. URMS is 3 RT upon m UMP, U average is 8 RT upon 5M. UMP is 2 RT upon M. For a gas at same temperature, for a gas means M is what? Constant. If you take the ratio U RMS, U average, and U MP, or you can take in increasing order UMP, U average, and U RMS. What is UMP? 2 RT upon M. Eight RT upon pi M and 3 RT upon M. If you take ratio, it will become root 2 because M will be cancelled, T will be cancelled. R is constant. This root 3. Its value is 1:128, 1.224, which implies what? U RMS is greater than U average. UMP. Value of UMP is less, but the fractions associated with UMP is what? More. The fractions associated with UMP is more. Done? Everyone is clear till here, Yanta?
Yes.
Next writing. Please finish it first. Next is kinetic gas equation.
Dense.
Good. First point, used for ideal gas. In kinetic theory of gas also used for ideal gas. consider n particles of a gas. Of a gas लिखा हमने, तो we fix the mass of one gas particle is m, and molar mass later we use it, but molar mass, and write it here only. Molar mass of gas you can take is capital M. Consider n particles of a gas. Present in a cubicle container of side L volume of container can take V. So V should be equal to what? L cube. If I assume that volume of container is V, what is the relation between V and L? L cube. RMS speed of gas is URMS. In calculation of pressure, collision between particles are ignored. When a particle of moving with velocity speed u collides with wall of container, it bounces back with same speed, but with same magnitude कह सकते हैं, same magnitude of speed. Here you can use velocity to clear the direction. With velocity u collide with the wall of container, it bounces back with same magnitude of velocity, but in ये इतना ना लिखे आप, with क्या लिख लें बताइए, माइनस यू, Now, the velocity can be resolved in three components because there are three directions. If I say it is x-axis, this is y, this is z, then u square can be written as ux square plus uy square plus uz square. If all the velocity are same, then u square is this. So what would be the value of ux square? 1 by 3 u square. Let's make a cube first, then only you can understand properly. In this direction we assume x, this direction we assume z, and this direction we assume y. So the x component, that is ux, will be along what? X direction. If I consider a face of the cube ABCD, then the ux component will be on the wall ABCD wall. There are 6 walls you can see in the cube. It will collide with ux velocity, the ux component. This length is taken as L. थोड़ी फिजिक्स पढ़ते हैं यहाँ पे, देखिएगा। momentum of a particle, बताते जाइएगा, before collision on the wall ABCD will be what? M into UX. Everyone understood this? बताइए.
Yes, sir.
Yes, sir.
When it will rebound back, the momentum of a particle after collision on the wall, it will be what?
Negative MUX.
Negative MUX. Change in momentum due to one collision on wall ABCD. क्या होगा बोलो?
0.
जीरो कैसे बेटा? Change.
Sorry, 2
But
MUX.
2 MUX.
2MUX. अच्छा बताइए, डिस्टेंस traveled during one collision, how much distance it has traveled? बताइए. मुझे ऐसा लिखिए, during one collision, a molecule travel to L distance. तो MUX निकालो minus MUX निकालो. Can you tell me? और इसको आप ऐसा लिखते हैं, that is distance traveled between two successive collisions with wall ABCD is what? 2L. Can you tell me how much time it took to travel? Yeah, how much time it has taken for 2L distance? Time between two successive collisions will be what? Distance traveled upon velocity. बताइए.
Yes.
Distance is what? 2L upon
2L.
is what? UX. So can you tell me number of collisions? So number of collisions per unit time will be what? It is just the reciprocal of this.
UX upon 2L.
Any doubt in this? पूरा physics है. You are learning the physics part basically. the number of collisions per unit time. This can be also referred as number of collisions on wall ABCD in 1 second due to component UX. We have already taken the UX component, and similarly we'll take UI component, UZ component like this. Therefore, change in momentum per unit time. Tell me the expression. बोलिए.
Two MUX upon T.
नहीं. Change in momentum is what? 2 MUX. हाँ, upon T कह सकते हैं. T हाँ कह सकते हैं. This is 2 MUX. This is for one collision. Per unit time कितने collisions हैं?
UX upon
Change in momentum for one collision is what? 2 MUX. But in 1 second, how many collisions are taking place? UX upon 2L. So total collisions per unit time due to component UX will be what? 2 MUX into UX upon 2L. So this can be also referred as rate of change in momentum due to UX upon 2L collisions on wall ABCD. इसकी वैल्यू क्या आएगी? MUX upon L. Any doubt here?
So
No, sir.
UX square हो जाना चाहिए ना upon
UX the whole square होगा.
हाँ हाँ वो
UX into UX.
हाँ ठीक. क्लियर यहाँ तक?
Yes.
Yes, sir.
Now tell me, what would be the rate of change in momentum due to on opposite wall of ABCD? Actually, you can directly write from here only, but we'll do a simplification. Opposite wall on opposite wall of ABCD. Same, because US component will be there. ABCD के अपोजिट, ABCD के अपोजिट ये वाला है, ये ABCD है, इसका अपोजिट ये है, दोनों के along UX will be there. हेलो, क्लियर है बेटा?
Yes, sir.
Yes, sir.
टोटल नंबर ऑफ कॉलम्स क्या होगा? देखिएगा, रेट ऑफ चेंज, we can directly write the result here only. I will tell you how. We'll use this factor, ये वाला factor, और काम हो जाएगा. Rate of change in momentum of one molecule on opposite walls along x direction will be 2 into mux square upon L. For n particles, क्या हो जाएगा? इंटू n. सिमिलरली along y डायरेक्शन क्या होगा?
2MUI square upon L into N.
z डायरेक्शन
2MUZ square upon L into N.
this. Total rate of change in momentum due to collisions on all 6 walls of container will be 2mn upon L this. Clear यहाँ तक? Hello?
Yes. Yes, sir.
This should be written as what? 2 into mn upon L into u square. What is u here? This u is basically is RMS speed. So RMS speed can be resolved in 3 ways. So this is a fact. Till here we have written. Total force क्या होगा? Same. Rate of change in momentum is what? Force. Rate of change in momentum is what? Force. You know this. The total force will be 2mn upon L into u square. तो 3 सेक्शन में हमने डिवाइड किया बेसिकली. This is resolution of velocities. Second thing is calculation of total rate in change in momentum. And third is calculation of pressure. Calculation of pressure. So P should be equal to what? F upon A. F is what? अच्छा, A की वैल्यू क्या होगी? What is A? Total area of the faces. A वही होगा ना? A की वैल्यू क्या होगी?
Yes.
6L square.
6L square. Mn upon L into U square upon 6L square should be 1 upon 3 M N U square upon
Upon 6, sorry, L cube.
1 upon 3 Mn U square upon what? V. From this, PV equal to 1 upon 3 Mn U square. This is your kinetic gas equation. In physics, you will again learn the derivation. पूरी आप पढ़ेंगे फिर से, but यही आपका kinetic gas equation. PV equal to 1 by 3 Mn U square. If you forget about the derivation also for chemistry, if you remember this equation, then also it will work. तो पूरी derivation को अगर आप भूल भी जाते हैं तो कोई खास फर्क नहीं पड़ने वाला. But you should know because it will be used in physics also. तो physics में पढ़ना थोड़ा आसान है. ठीक है, यहाँ तक डन.
Yes, sir.
आपने कहाँ तक लिखा है? इसमें कहाँ तक लिख लिया बेटा? बोलो.
L.
Sir, हो गया लिख के.
पूरा लिख के हो गया? वेरी गुड. जो लास्ट वाला पार्ट है भी कंप्लीट कर लीजिए. थोड़ा ब्रेक ले लीजिए. 9 o'clock स्टार्ट करते हैं.
Okay, sir.
See, alternatively, what we can do, we already calculated the momentum change in one direction. देखिए कितना आसान है. Momentum change per unit time in x direction is what? M ux square upon L, and ux can be replaced by what? Ux can be replaced by M
U
U
square by 3.
by 3 ठीक है, by 3. Force is equal to change in momentum per unit time, that is mu square upon 3L. Pressure only on that wall, only one wall, because in the previous case we have taken the all walls. Pressure P is equal to force upon area mv square upon mu square upon 3L upon L square. It will be mu square upon 3L L cube. Therefore, pressure will be equal to what? Mu square upon 3V, that is 1 by 3 1/3 mu square, या ऐसा लिख सकते हैं. This is for one particle. This is for only one particle. So total pressure by n particles will be equal to n into 1/3 mu square upon v. So PV equal to what? 1/3 n mn लिखा था हमने. mn mu square. Difference is what? ये बॉक्स बना के लिखते हैं. Here A is area of one wall, one face, and जो ऊपर हमने A लिखा था, here A is what?
Area of all wall.
All wall या six face. Six face और six walls तो नहीं कहते हैं, चारों तरफ wall होता है, six face कह सकते हैं. This is also very good derivation, simple derivation. यहाँ तक डन.
Yes, sir.
ठीक है.
Yes, sir.
हाँ. If n equal to na, na is what? Avogadro's number. Then m into n becomes m into na. It becomes what? M. What is m? Molar mass.
Molar mass.
If n अगर na बन गया तो 1 mole बन गया ना. 1 mole particles हो गया. तो 1 mole particles का mass क्या होगा? Molar mass. The equation will become PV equal to 1/3 m
U square.
u square. U is what? RMS. URMS. U is what? URMS. ठीक है. Any doubt here?
No, sir.
Again we can write 2/3 1/2 m u r square u square. Again I will mention it here. What is u here?
URMS.
RMS speed, RMS velocity. P equal to 2/3 into कर सकते लिख सकते हैं ना. 2 cancel हो जाएगा.
Yes.
So what mu square क्या हो जाएगा? PV equal to 2/3. What will be this? Average kinetic energy for
1 molar.
1 mole.
of gas. So average kinetic energy of
Hello, sir.
sir.
Sir, can I leave?
Why should you leave?
Sir, I'm going for vaccination.
हाँ बेटा, okay.
Chachra particle of gas 1 is equals to 3/2 kT.
ठीक है, फिर तो ठीक है.
हाँ.
The questions I gave, so try to solve the questions. Take the screenshot, ठीक है ना? Take the screenshot, write the problem in your notebook and solve it. Till then, I will leave the fourth question. Fourth question you can try at home. Solve the questions. First question का solution क्या होगा बताओ?
7/8.
ये करना, which formula you have to apply? Kinetic energy for n moles will be what? 3/2 nRT है ना? तो kinetic, अच्छा, number of moles इसमें कितने होंगे? 8/28 moles. Sorry, both has different na. It will be 8/28 and this is 8/32. ठीक है, तो 3/2 nRT for n2 ratio 3/2 nRT for 2. So 3/2 into 8/28 into T. T is constant. 3/2 into 8/32 into T. 8/7. Second one हुआ किसी का?
No, sir.
सेकेंड वन में क्या जानना है सबसे इम्पोर्टेंट? देयर इज अ फॉर्मूला जो आपने देखा होगा, 3RT/m का सिंप्लीफाइड फॉर्म क्या था? 1.5 into 10⁴ into T/m. और m for CH4 कितनी होगी? 12 + 4 into 1 16.
16.
Any doubt here?
No, sir.
ठीक है, अब पूछता है दी RMS velocity at T1 and most probable velocity at T2 will be same ही है दोनों का वैल्यू. तो 3RT1/m should be equal to 2RT2/m. From this m cancel, r cancel, 3T1 equal to 2T2. अब 400 and 600.
Yes, sir.
T1/16 should be equal to 7.9 into 10⁴. Because serious unit, the molar mass should be in the gram. If you simplify it, T1 will be, it will be cancelled. कोई tough calculation नहीं है. You can cancel it. 5 से cancel हो जाएगा. And 3 into 400 will be 2 into T2. From this T2 will be 600 Kelvin. Third one is very simple. In third one, calculate the temperature at which RMS velocity. तो ये तो simple है. T1/m1, T2/m2 लगा देंगे. So T of hydrogen upon 2, T of oxygen upon 32. So T of hydrogen upon 2, T of O2, that is 47. 47 means 320. Therefore, TH2 is 20 Kelvin.
20.
ठीक है ना सब लोग?
Yes, sir.
Yes.
बट ट्राई, कुछ नहीं, बहुत सिंपल है वो. नाउ अब थोड़ी डिफिकल्ट वाली पार्ट है. I will tell you, don't have to learn the equations. We have to learn only the graph. जो ग्राफ होगा, ग्राफ बहुत सिंपल है। इस इक्वेशन का जो ग्राफ बनाएंगे, इस इक्वेशन से रिलेटेड जो ग्राफ बनेगा वो भी बिल्कुल ऐसा ही होगा सिर्फ, और कुछ नहीं ग्राफ में। You have to understand this graph only. But still I gave the complete details of it. Distribution of molecular velocities. Because if I keep a sample, if I've taken a sample of gas, and if you study the velocities of all the molecules, then you cannot calculate the velocity of individual molecules because it is changing continuously. But any time if you observe the fraction of molecules will be having same velocities. If it is having same velocity, it means it will be constant throughout the time if T is constant, temperature is constant. So he studied that distribution and he plot a graph. He gave an equation also. So what is the equation? dN equal to 4 pi n. N is the total number of particles. M is the molar mass. R is a constant. T temperature. Exp means exponential. So that's why we have written e raised to minus mu square. So it's a different way to write it. E raised to something, exponential raised to something can be written as in this format. Minus mu square upon 2r into u square into du. Now what is du? Change in velocity. U is just a velocity. U is just what? Velocity. So dN is 4 pi n m by 2 pi rt raised to 3 by 2. If you see, this part is constant only. So dependency on the U is only this part and something. Again, we have written the same thing. But what we did here, we kept it together, and this is a different part. This is algebraic, this is exponential. One is increasing function, other is decreasing function. I will tell you how to write it. What is dN? dN is the number of gas particles having velocity between u and u plus du. If you change the velocity by du, how many particles are associated with that change? It is dN. N is the total number of particles. T is temperature. M is molar mass. Molar mass can be molecular mass as well as
Atomic mass.
atomic mass. Again, I have written it, but I have written different forms also. What I did, I brought the N in the left hand side in the denominator. Written this. What is dN upon N? Can you tell me? dN is the number of particles. N is the total number of particles. So it is fraction. So dN upon N is what? Fraction. If you divide the fraction by du, there's another expression 1 upon N dN upon du. This. Or if you keep only dN upon du, the equation will be this. Most important is the middle one. The graph will be also plotted between, this should be taken as a y-axis, and the other variable is what? U. We have finished till here. So please complete till here in your notebook. And I didn't explain much. I've given you some examples of equations, how to write the equation. dN is the number of particles. dN upon N is the fraction. dN N upon du is the fractional change per unit velocity. So I will again explain properly everything, but go through the equation. You can only learn today's class that dN is composed of two factors. One is algebraic and other is what?
Exponential.
That's it. It means the third equation I told you. Again, I will write it. This is what?
Algebraic.
Algebraic.
And this is
Exponential.
Exponential.
So can you tell me, if u increases, what will happen to u square? Increases.
Increase.
Yes, sir.
But if I talk about the exponential part, if u increases, what will happen to the exponential part?
That will
Sir, decrease होगा.
Decrease होगा because minus sign लगा होगा, है ना?
Yes, sir.
Yes.
Algebraic part. This is exponential. ठीक है? What you can conclude here? If u increases, e raised to minus mu square upon 2rt decreases, and this part, increases,
U increases, U square increases.
है ना? Algebraic part,
Increases.
algebra increases. This is dominates at low velocity. This dominates at high velocity. Dominates means that dn wala part, dn will increase. dn will increase at low velocity and dn will decrease at
High velocity.
high velocity. क्लियर है? हेलो,
Yes.
ठीक है. जो हमने यहाँ मेंशन किया है, यहाँ भी लिख देते हैं. है ना? यहाँ मेंशन कर लेते हैं. तो इसलिए ग्राफ कैसा होगा बनाएंगे तो पहले ग्राफ क्या होगी? लो वेलोसिटी पे ग्राफ, अगर यू लो वेलोसिटी ले लिया, यहाँ पे ग्राफ बढ़ेगा क्योंकि डीएन क्या होगा? बढ़ेगा. फिर बाद में वेलोसिटी बढ़ेगी तो डीएन कम हो जाएगी.
Decrease.
ये बताएंगे आपको नेक्स्ट क्लास में अच्छे से. जस्ट फिनिश द नोटबुक टिल हियर. क्लियर सबको?
Yes, sir.
Yes,
Yes,
sir.
sir.
ओके बेटा, थैंक यू.
Thank you, sir. Bye, sir.
बाय.
Bye, sir.